Okay, let's continue. Let's see, where did we last end off with? Oh yeah, function pointers. Okay, so automating the Dear John letters. Imagine you're writing a mail merge program to send out different types of messages to different people. One way of creating the data for each response is with a struct like this. So an enum with response type, either dump, second chance, marriage. This book is obsessed with dating for some reason. I'm sorry, I just have to say that. Response type is a dump, second chance, marriage, and you'll have a struct that is, I guess, a response. And it looks like the person's name in who you want to either dump, give a second chance of marriage, and then the type of the response. One of these three. Okay? The enum gives you the names for each of the three types of response you'll be sending out. And that response type can be recorded against each response. Then you'll be able to use your new response data type by calling one of these three functions for each type of response. I see. So custom functions to write letters based off of the response. Sure. Okay, so we'll have, dear blah, or that name, so that person, like dear John, I guess. Unfortunately, your last date contacted us to say that they will not be seeing you again. And the second chance would be like, dear John, good news. Your last date has asked us to arrange another meeting. Please call ASAP. Dear John, congratulations. Your last date has contacted us with a proposal of marriage. Ooh, could be too soon. Okay. So now you know what the data looks like and you have the functions to generate the responses. Let's see how complex the code is to generate a set of responses from the array of data. Okay. All right. So let's have another go at this. So yeah, let's fill it out. I think, yeah, it's just time to make another project. So we'll call this Dear John. And then we'll have main.c. And let's get right on to it. So it'll be include dio.h, main, and argc, character pointer to an argv array. Sorry, I'm not used to this keyboard again. Been a while. Then let's say return 0. Then let's actually write these down here. Again, like to type it out. Muscle memory, just to get used to C again. Been at work for a while. It's been pretty busy, so haven't had time to sit in front of the computer here. Oh, we need to actually write this down here. So enum response type is going to be dump, second chance, marriage. Okay, then we'll have the struct. Type that struct, so we can use the struct as if it was its own separate type, like response R, as we have in our function signature. And we'll have a pointer to a character that represents the name, and then we'll have the response. Okay, so now we're in business. All right, so printf dear blah puts. Unfortunately, your last date contacted us to put say that they will not be seeing you again. Okay, the next one is going to be second chance. Okay, print F, dear John, I guess. Puts good news. Your last date has asked us to arrange another meeting. Please call ASAP. Okay, and then finally the weird one, marriage. So soon. Okay, printf dear %s r.name s congratulations, your last date has contacted once again us with a proposal of marriage. All right, now we have these three functions that we can call. So let's write our main function here. Let's just fill in the blanks. So response R, these are going to be the guys that you have. So an array of response structs. So we'll first have, let's do it this way. Dot name is going to be Mike. Dot type is going to be dump. The next one, dot name is going to be Lewis. And then dot type is going to be second chance. Then we're going to have Matt. And then that is going to be given a second chance. Then we'll have, let's see who else. Lastly, we'll have William. And he deserves marriage. Okay. All right, so then we'll have a for loop. So I'll just do an I in here. I is 4, I plus plus. Okay. Switch. So what are we looking at here? I think we're going to be looking at the response. So we're going to iterate through every response, it looks like, in this response R array. And I think we're going to be looking at, in this case, it looks like the type of response to call the appropriate method with the response R object. And I think that's all there is to it. So we're going to do it this way. Response, cur response is going to be R at I. And then we're going to be doing a switch on cur response dot type. And then we're going to have a case for, looks like dump. So when we dump, we call dump cur response. Then we'll break. Then we'll have case. Who else? Second chance, it looks like. So we'll do second chance. Cur response. Break. Then finally, default will be marriage. Cur response, because that takes in a response type. So these are all response type structs from the current, I guess, structure in our response R struct array, and that gets passed into each of these individual functions. So that's looks like that's it. So looks very straightforward to me. Let's look at the answers. So looks like, so we have this is they did R at I. We can just set it as a variable like this, and then basically we check the type in the switch, and then we'll pass in the current response here. So that's about it. Okay, so let's take a test drive on this, and we'll just go into our Dear John gcc main.c, and let's run it. A.out. So, dear Mike, unfortunately, your last date has contacted us, say that they will not be seeing you again. So that's dump. And Lewis and Matt had second chances, so second chance. And then William was marriage. So that looks about right. And here, the book has pretty much the same thing. It says, well, it's good that it worked, but there's quite a lot of code in there just to call a function for each piece of response data. Every time you need to call a function that matches a response type, it will look like this. Okay, true. They told me a coder forgot a set break statements, and that meant I ended up with this guy. Oh, that's a joke. They told me a coder forgot a set of break statements, and that meant I ended up with this guy. Okay. And what will happen if you add a fourth response type? You'll have to change every section of your program that looks like this. So you'll have to basically, if you add a fourth response type, you'll have to create a function for that fourth response type, and you have to update your switch statement to check for that type, and then you have to call that function. So it can get pretty crazy. So soon you'll have a lot of code to maintain. It might go wrong. Fortunately, there is a trick that you can use in C, and it involves arrays. We can actually create an array of function pointers. So remember that the type of the function pointer is indicated by first the return type, the name, which you can always vary, and also the parameter list with its types. So if the return type and the parameter list are pretty much the same, and you can just like kind of genericize, basically give a generic name, you can pretty much make your own type, this function pointer type. And then you can store all that into a collection because they're all commonly the same. They're all the same type. So we can create an array of function pointers. The trick is to create an array of function pointers that match the different response types. Before seeing how that works, let's look at how to create an array of function pointers. If you had an array variable that could store a whole bunch of function names, you could use it like this. So these are all the function names in an array of replies types. Okay, but that's not really correct, right? Because that's not like, well, that is correct because replies is basically the variable name, but how do you define the type of replies? So I think that's what we're going to get to here. But that syntax doesn't quite work in C. You have to tell the compiler exactly what the functions will look like that you're going to store in the array, what the return types will be, and what parameters they will accept. That means you have to use this much more complex syntax. So this type of array here, and the label replies. So again, the structure is return type, make it a pointer variable, and since it's an array of the responses, like it's an array of functions to those responses to print them out. Yeah, you'll have this bracket here, and then the type, the parameter list. So that will be basically the type and the label, which is always required. You need the identifier. So this is the identifier of your variable declaration. It has to be an array because you want to store all this in an array. If you don't have the square bracket, it means that it indicates one of these only. But since you're having a collection of 3, that's why you need the angle bracket. So equivalently, if you think about it, so if we had something like, let's just make it like analogy once my tablet loads. Come on. Okay. So we think about it this way, where let's say we had a character array, right? So buffer, so B, for example. The equivalent of this is going to be void, for example. So return type is going to be pointer, replies, then it'll be like this, and then the response equals blah 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 blah. Right? So then if we had something like this, one single character, it's equivalent to just something like this. Notice how I don't have the square brackets in this case. And then that will only have, one single thing. So that's the analogy I'm like trying to communicate here. So Yeah, so how does an array help? Well, look at the array. It contains a set of function names that are in the exactly the same order as the types of the enum. So dump, second chance, marriage, marriage. This is really important because when C creates an enum, it gives each of the symbols a number starting at 0. So dump is internally, the enum value of dump is 0, the enum value of second chance is 1, and the enum value of marriage is 2. And that actually corresponds to the indexes of these functions here in that function pointer array. 0 is dump, 1 is second chance, 2 is marriage. So you can actually use these and treat them as indices into the replies function pointer array. More appropriate like this, right? So this is how you would actually think of it as. So dump is 0, second chance is 1, marriage is 2. And that's really neat because it means that you can get a pointer to one of your sets of functions using a response type. So you'll pass in the response type as an index because that's actually a number. Second chance here is the value of 1, so index 1. So what is the function pointer in the second element, which is indicated by the index 1 in the replies array? That is actually the second chance function. So these two are essentially equal because this returns back you're getting a function pointer, and second chance itself is a function pointer. So function pointer equals to function pointer. Good. So let's see if you can use the function array to replace your old main function. So it's a tough exercise, but I think we could do it. Yeah, let's do it. It says it's tough. So, okay, this exercise is quite a tough one, but take your time with it and you should be fine. You already have all the information you need to complete the code. In this new version of the main function, the whole switch case statement that was used before has been removed and needs to be replaced with a single line of code. This line of code will find the correct function name from the replies array and use it to call the function. Cool. So let's try it. So let's remove pretty much the switch statement, and I think we just keep the for loop. So boom. Okay. So we know this. We know that cur response.type is going to return us an enum value, and that can be thought of as index to a function pointer array, because enum values are just numbers. So that's what we're going to be using. We're going to be using that value. So we can say something like, in this case, we have a replies function pointer array. So we declare it like this. Oh, it's outside our main. So outside our main. So we'll have void replies response. So remember this. This is the return type. This is our identifier. We will put it as a pointer because we're storing function pointers, and there will be a collection of them, which is an array. And then we always have to give the parameter list of the types. So just keep remembering that fact, and practice will make perfect, I guess. So we'll store all these function pointers, so they all reference these functions up here. So dump references dump, second chance references second chance, marriage represents marriage. So you have to think about functions are just basically data too. They're just variables too. So it just has a different type associated with it, and that's this weird function pointer syntax. So we have replies now. So we can actually index into replies, for example, like this, at a specific index, response.type, since that is our cur response.type. That is actually an enum value, which we can use as an index. And what we can do is we can just call it, in this case, with our cur response. And that's, I believe, all there is to it. It's a one-liner. So we can take our function stored here and use it to call it. And you know what? I think it might be easier to even store it as a variable and just see what it looks like. So we call it response handler. Okay, and no square brackets. We don't need these because we're just getting one single function pointer of that type, and that would be I guess replies at cur response dot type. So we'll get that returned here, and we could change this to be response handler, or we can just rename this to handle response, just to handle response, and we'll treat it like a normal function call because we've stored it into a variable already. Let me just kind of adjust this. Yeah, we stored this into a variable called handle response already. Assign this function pointer to this identifier of the same type. This is how we declare a type here. And then we'll just kind of reference it like any other piece of data, and then use the function call syntax to just call it with our argument. So if we do that, technically we should have the same effect. So yeah, so it still works the same way. And let's see what the answer was. Ours is a little bit different. So yeah, so they did it the first way we did it, where they called replies. They took the enum value, treated as an index into the replies array to get the function pointer, and then called it by passing in the current response. So I think this is more confusing. I think it's better to always like break it down to like separate variables so that you can actually understand what's actually going on step by step. But that's just my preference. So um, yeah. So anyway, it is showing that you should be getting the same results here. So now when you run the new version of the program, you get exactly the same output as before. So all these letters here. And the difference now, instead of an entire switch statement, you just have this call to a function using the function pointer thing. If you had to call the response functions at several places in the program, you won't have to copy a lot of code. And if you decide to add a new type and a new function, you can just add it to your current array. So for example, a lawsuit is a new response type, and you just give it the corresponding function to execute whenever a response type is lawsuit. Arrays of function pointers can make your code much easier to manage. They are designed to make your code scalable by making it shorter and easier to extend. Even though they are quite difficult to understand at first, function pointer arrays can really crank up your C programming skills. Yeah, I think they're a game changer because it allows you to write very modular code at that point. So it's pretty cool. Anyway, bullet points. Function pointers store the addresses of functions, so they are pointer to functions. Function pointers are pointers to functions. They are an address. The value is an address of these pointers, and then you can dereference that address to get to the real function and call it that way, just like any other pointer. So the name of each function is actually a function pointer. So we just said main. That is actually a function pointer. Marriage is a function pointer. We reference that function. If you have a function shoot, then shoot and address of shoot are both pointers to that function. So these two are equivalent. You declare a new function pointer with return type, the identifier name, and the parameter types list. So this could be one or more, or actually it could be zero or more. These param types could be empty, or could be lots of parameters. If fp is a function pointer, you can call it with fp whatever params. So same like any other function. Or you can dereference it and then kind of just call it this way too. It's the same thing. The C standard library has a sorting function called qsort, and qsort accepts a pointer to a comparator function that can test for equality or inequality. Okay, let me answer this. All right, so the comparator function will be passed 2 pointers to 2 items in the array being sorted. So remember, the comparator function again is the pointer to a function that qsort accepts, the quicksort function in C, so that you can customize how items are compared with each other given some sort of array. If you have an array of data, you can associate functions with each data item using function pointer arrays. Cool. So why is the function pointer array syntax so complex? Because when you declare a function pointer, you need to say what the return and parameter types are. That's why there are so many parentheses. This looks a little like the sort of object-oriented code in other languages, is it? It's similar. Object-oriented languages associate a set of functions called methods with pieces of data. In the same way, you can use function pointers to associate functions with pieces of data. Hey, so does that mean that C is object-oriented? Wow, that's awesome. No, C is not object-oriented, but other languages that are built on C, like Objective-C and C++, create a lot of their object-oriented features by using function pointers under the hood. Cool. Make your function stretchy. So, sometimes you want to write C functions that are really powerful, like your find function that could search using function pointers. But other times, you just want to write functions that are easy to use. Take the printf function. The printf function has one really cool feature that you've used. It can take a variable number of arguments. So remember, printf, you can actually pass in as many arguments as you want. How do you do that? And you've got just the problem that needs it. So let's try it. Down in the head first lounge, they're finding it a little bit difficult to keep track of the drink totals. One of the guys has tried to make life easier by creating an enum with the list of cocktails available and a function that returns the prices for each one. So based off each of these, cocktails, we can get the price of each one of them. So return this, okay, sure. And that's pretty cool if the head first lounge crew just wants the price of a drink, but what they want to do is get the price of a total drinks order. So, based off the price of zombie, we can just run this code here. See, price enum drink D. Drink is an enum. So we pass in this zombie enum value into the price, and based on that, we get 589. But we want to pass in more than that. We want to pass in, what we call like total, for example. We pass in the number of drinks that we want to list out, and then followed by all the drinks in order. So that's how we know when to stop, I guess. Given 3, we'll run through 3 drinks, totaling them up. So they want a function called total that will accept a count of the drinks and then list the drink names. Okay, sure. Okay. Variadic functions, that's what they're called. Functions that will take like a varying amount of arguments, as many as you want. So a function that takes a variable number of parameters is called a variadic function. The C standard library contains a set of macros that can help you create your own variadic functions. To see how they work, you'll create a function that can print out a series of ints. So basically, by passing in or creating a function that will print ints, the first argument here is the total length of how much ints should be printed, and then the subsequent arguments will be all the integers that you do want to print. So it'll run through as many times the first argument specifies. In this case, 3. It'll take 3 of them. Remember, C is not smart. In a way, C is kind of dumb in a way that you have to always specify the length of something. It's not dynamic, it's not convenient, but it's simple in this case. So, this is a little bit complicated, but we can see. Why don't we just write this code? Yeah, why don't we just write this code? So, create a new project again. We'll call it Variadic Functions. And open main.c. Okay, we'll do include std_arg.h, and then I guess we'll have well, let's just start with the main, int main. Let's just do a normal main. And then we'll have void print ints, int args, and then this dot 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 syntax seems to be important. And that means like, okay, well, here's the int number of arguments, and then here's the rest of the arguments here. So that's valid C. And this is going by a macro called VA list that gets included when you include stdarg.h. So you'll get this data type here, and you'll have to specify in this order. AP, VA start will be AP, and then the args. And then you'll have your code that will do stuff. So code that will process the arguments. And after that, when you're done, when you're ending, you'll do VA end with this AP thing. So basically saying, hey, no more. So I think these are not really code itself. These are just macros that will be replaced by the preprocessor. So let's do it. Let's write a for loop, a simple for loop that can handle this. So for int I0, I is less than args, I plus plus. Then we'll do printf argument %i, new line, and then va arg ap int. So I'm guessing ap is like a pointer, some sort of thing, and then va arg is just basically to get the current piece of data in your list. In this case, I'm guessing we have to specify the size, the data size. In this case, if we have an array of ints, then each one is an integer. So, give, process maybe the current value pointed by AP and make sure it's int size so it can move through the list, by incrementing the number of bytes necessary. Maybe it's doing that. Okay, so then if we have an array of ints, for example, print ints, I think we need stdio.h too. We're going to use printf because printf is in stdio.h. So we'll do print ints with 3, and we'll have 79, 101, and 32. And then I think that's all there is to it. So yeah, the variable, let's see how we start this. Okay, so the variable arguments will follow. The variable arguments will start after the args parameter. Okay, this is a normal ordinary argument that will always be passed. This will loop through the other arguments. Okay, so yeah, let's break it. I guess they're going to break it down. Oh, in the order, maybe. So include stdarg.h header. All the code to handle variadic functions is in stdarg.h. So you need to make sure you include it. Got it. Then tell your function there's more to come, and this is what the ... is. Remember those books where the heroine drags a guy through the bedroom and then the chapter ends? Is this another dating reference? Yeah. Okay. Well, that ... is called an ellipsis, and it tells you that something else is going to follow. In C, an ellipsis is after the argument of a function. Wait. In C, an ellipsis after the argument of a function means there are more arguments to come. Okay, so that tells C that there's going to be more than just one. So create a VA list. The VA list will be used to store the extra arguments that are passed to your function. So here, these are all the arguments, a list of arguments that will be passed into our function. Say where the variable arguments start. So C needs to be told the name of the last fixed argument. In this case of our function, that'll be the args parameter. So this is like start at here. Start at this args, I guess non-inclusive. So the ones coming after that. So then read off the variable arguments one at a time. Now your arguments are all stored in VA list, and you can read them via the varg.varg. Wait, now you can read them with varg. Okay, varg takes two values: the VA list, okay, so the list of the arguments, and the type Oh wait, where is it? Right here, right here. And the type of the next argument. In your case, all the arguments are ints. So I guess it needs to know how to jump across memory by how many bytes. If finally end the list with the VA end and that list passed in. Okay, and then we can call our function. Sure, let's do it. Let's do it. Let's see if we can print something out. Variadic functions, GCC main.c. Boom. Pretty cool. All right, so functions versus macros. A macro is used to rewrite your code before it's compiled. So it's part of this pre-processing step. It's not real C code. It's preprocessor code in this case. The macros you're using here, VA start, VA arg, and VA end, might look like functions, but they actually hide secret instructions that tell the preprocessor how to generate lots of extra smart code inside your program just before compiling it. Wait, why are VA end and VA start called macros? Aren't they just normal functions? No, they are designed to look like ordinary functions, but they are actually replaced by the preprocessor with other code. Okay? And the preprocessor just runs before the compilation step. Yeah, that's true. So preprocessor and then compile and then link. Among other things, the preprocessor includes the headers into the code. Can I have a function with just variable arguments and no fixed arguments at all? No, you need to have at least one fixed argument. So basically, this one is our fixed argument in order to pass its name to VA start. What happens if I try to read more arguments from VA arg that have been passed in? Random errors will occur. Again, it's more like a list of things. So you go out of bounds and bad things happen. Yeah, that sounds bad. Pretty bad. What if I try to read an int as an argument? Wait, what if I try to read the int argument as a double or something? Again, random errors will occur. You probably won't get what you want. So, okay. So, now it's time to do this total thing. Okay. So, using the price function from a few pages back, complete the code for total. Okay. Let's do it. Same thing. We're going to write a function, total, int arg, so the number of arguments, dot, dot, dot. Like, and again, it could be anything you want it to be. Double total equals this. And we just return total. And I think it's just a for loop. So for int I equals 0. And then we decide the args is going to be the number of arguments available. So we say I is less than args, I plus plus. And then we'll say something like total plus equals. So we're going to add to it. Maybe I can just make it clearer. Plus VA arg, AP, and we'll say double. Is it double? Or is it int? Let's see what monkey gland was and all that stuff. Ah, no, these were indeed doubles. And then we want to then have enum drink. Mudslide, fuzzy navel, monkey gland, and zombie. Okay. Okay. So we'll have an enum here. What's VA? Why is VA our identifier APs? Oh, okay. So undefined. Okay. So we had to also do the VA list thing. I think that's like the very first thing we had to do. No, we don't. Maybe not. Let's try. It must be in the same order though. AP, VA start, AP args, and we have to end it somewhere after this. After we're done processing, we do VA end AP. And that looks right. So we're gonna. Ooh, what happened? So we're going to VA end. I think it's just trying to be too smart. AP. There we go. Okay. So we're gonna since each element's gonna be a double, we're gonna have to jump through whatever double bytes for every single argument. We'll total them up and we'll return it. And then we'll just follow this format here, is what they say. Strict format, actually. So yeah, VA list AP, VA start, and I. Ooh, what is this? VA enum. Oh, forgot to. So that's not how it works. We had to get the price of it. Okay, so we're missing code. And total is spelled wrong. Ah. So this is not the list of prices. This is the list of enums. Okay, so this will be enum drink. Is that how we do it? Yeah. So we'll get that argument and then we'll pass it into price. So this one here, this VA arg will return us the price, or the, how should I say this? Yeah, the drink, the enum drink, like the type of the drink, and then we'll pass that into price. Where is price again? Anyway, I think it's that switch statement right here. So we'll have a double price while we're at it with enum drink D. Let's just answer a message. Okay, so we'll just copy this over. Paste mudslide. Return, so we don't need any breaks. Okay, and then last but not least, return 0. No defaults. It's either you have something or you just go return nothing. 0. Okay, so this will get us back the enum type. We pass that into price, which is an enum drink here. Get that price, total it up. Okay. All right, test drive. So let's write a main function for ourselves. And we'll do this. Printf price is %.2f, and we'll say total. So that's our new function with the Variadic function here, with how many? 2, and monkey gland, mudslide. We'll also printf. What do we have? Price is %.2f. New line. Total. We'll have 3 drinks this time. Monkey gland, mudslide, and fuzzy navel. Then we'll have one more, which is only 1 drink. Price is %s. Oops, not %.2f. New line. Total 1 zombie. Then we should be able to compile that and get a total. See if we can match this here. So GCC, a.out, 1161, 692, 589. Awesome. Okay, so our code works. Pretty cool. Yeah, baby, I could remember these even after one too many monkey lives. Okay. Functions that accept variable number of arguments are called variadic functions. To create variadic functions, you need to include the std_arg header file. So yeah, in order to get the benefits of variadic functions, we have to include the std_arg.h header file. The variable arguments will be stored in a VA list, and you can control the VA list using the VA start, VA arg, and VA end. You will need at least one fixed parameter. Be careful that you don't try to read more parameters that you've been given. And you always need to know the data type of every parameter you read. So remember, C is very manual. So we have to specify the length and the type. So yeah, I'm done with another chapter. Next, we'll go to static and dynamic libraries. So I'll leave that for next time. Right now, let's commit our code. So we git add. Forgot to add that. Hey, there we go. Commit more function pointers and variadic function. Okay, and we're good. Okay, see you next time. Bye.